Let's run through how to do an ANOVA with all 6 steps. Now these are going to look a little different. Like each time I teach you a test, something differs just a little bit. But I do want to point out that these are subtle little differences. The main concept of the 6 steps are the same, but there's probably more change this time than we've seen before. So let's start with a prompt. A study compared the felt intensity of unrequited love among 3 groups: individuals who are currently experiencing unrequited love, individuals who had previously experienced unrequited love, and individuals who had experienced unrequited love and described their experiences retrospectively, and individuals who had never experienced unrequited love but described how they thought it would feel if they were to experience it. So determine if felt intensity of unrequited love differs by experience. In other words, unrequited love is when you love someone and they don't love you back and it's really painful. And they wanted to know if that pain of unrequited love was the felt intensity of it was the same for those who currently felt it, those who felt it once before and remembering it, and those who never felt it and are trying to imagine what it would be like. So notice that I have 3 groups: current, retrospective, and imagined. If I had only had 2 groups, current and retrospective, I could do an independent T. But because I have 3 groups, I have to do an ANOVA. I'd like to point out that the data are going to look like this, which looks a lot like how the independent T would have come to us. But in the independent T, we would have just had 2 conditions. But now that we have 3 conditions, we have to run an ANOVA. So let's do our 6 steps. Our first step is going to say, does felt intensity of unrequited love differ by experience? Notice that I'm not specifying, is this one above this one or this one below this one, or are these 2 different? I'm being very generic in my statement, and that's required of the omnibus test for the ANOVA. We aren't going to get into specifics unless we find a significant difference. So we can do step 2 in 2 ways. Let's try the trick that I've always taught you, which is take your research question and turn it into a statement and then add not. So for step 2, if I were going to do the steps we've been doing in the past, we could say for the null, felt intensity of unrequited love does not differ by experience. And then for the alternative, felt intensity of unrequited love differs by experience. Notice this rule still works for us. Let's see how this would look as symbols. So the null would be mu1, mu2, mu3, where 1, 2, and 3 stand for current, retrospective, and imagined. But notice that for the alternative, I'm not writing mu1 does not equal to mu2 does not equal to mu3. Because that image there, mu1 not equal to mu2 not equal to mu3, would suggest that I know that all are not equal from each other. But I don't know if that's the case. All I know is there's a difference in there somewhere, and I don't know where it is. Remember, the omnibus test has a bag. It's not telling us where the difference is. They're just saying there's something in there. It may be that mu1 doesn't equal mu2. Or maybe they do, and it's mu2 that doesn't equal mu3. Or maybe they're fine, but it's mu1 that doesn't equal mu3. See how there's so many different ways that this could manifest? And since any of those would be sufficient as an alternative, we are only going to just say that the null is false, or they're not all the same. So even though not all the same is not a symbol, it's a phrase, that is the closest we can do for symbols for the null hypothesis. So I like to say the alternative is they're not all the same. Now let's talk about step 3. We talked about how we would need 2 degrees of freedom to identify the critical F value that would determine our rejection region, and any score above that would be in the rejection region. I feel as though this might be an unnecessary step. I would need to have you have a new table, and now it's kind of more complicated by 2 sets of degrees of freedom. But I'd also like to remind you, we've been getting better at using JASP, and JASP always gives us the probability value. And no matter which test we do, an independent T or a dependent T or an ANOVA, if the p-value is less than 0.05, that means we're going to reject the null. So for step 3, we can now say where we're going to reject the null if the p-value is less than 0.05. I'd like to shift gears to using this as our rejection region because This will allow us to use this phrase for all future tests. We don't have to look up new critical T's and F's because this is always going to be true. Any p-value less than 0.05 means that we're going to reject the null. So now we have to do step 4, where we are going to calculate this in JASP. So let's shift over to JASP and see how to do this in JASP. Now that we have our data set open, let's go ahead and run the ANOVA. And there's another practice run through this, so if I do something and you want to see it again, go ahead and look at the other example of running an ANOVA in JASP. So notice that we have nominal variables and then numbers. This is the way our ANOVA will require it to look. So we're going to click on ANOVA and then ANOVA again. And our dependent variable is going to be our outcome variable, and fixed factors are going to be our independent variable. In other words, our dependent variable is our outcome of interest. So this is the outcome. The fixed factor is the thing that we think is impacting the outcome variable. So we want to see the felt intensity of unrequited love as our outcome variable, and the condition would be what condition you're in, imagine, retrospective, or current. That's going to be in our fixed factor. So before we go further, let's check our data. We can see that it says condition and residual. And remember how we calculated ANOVA was we took the sums of squares between divided by the degrees of freedom to get the mean squared between. And we then divided the mean squared between by the mean squared within, and we got our F value. We have all of that here. The sums of squares between, here it's labeled condition because condition is our between factor item. So this is the sums of squares between divided by our degrees of freedom equals our mean squared between. Our sums of squares within, remember within was just this random error. Sometimes people call that residual or error. So our sums of squares within divided by our degrees of freedom within makes our mean squared within. Our mean squared between divided by our mean squared within equals our calculated F value. So our calculated F value is 8.727 and our probability is 0.008. This means the probability of getting an 8.727 or higher in the F distribution is very small. It's 0.8%. Since this is less than 0.05, remember anything that's less than 0.05 is significant, then we can move forward with our post hoc test. This is our omnibus test results. Because this is significant, we can do post hoc. If this were not significant, let's say the p-value was 0.8, then we would stop here and do no more. But it is significant, so we can run our post hoc test. If you don't remember how to interpret this p-value, go back to the video that I have for p-values. Since we can do a post hoc, let's scroll over to the left and do some post hocs. So we're going to click on post hoc test. And then I select what variable I would like to run the post hoc test on, and it's going to be condition. And what we will be looking at is if we have the same sample size for each condition, then we can run the Tukey. If we had different sample sizes between the conditions, we would violate the assumption of the Tukey and then would need to do the Chaffee. The Chaffee is a little harder to find significance, so it's more conservative, so it's not your knee-jerk response to want to do it. However, it can handle when we don't have the same sample size per group. And then we won't be doing Bonferroni in this class. We'll just be debating between the Tukey and the Chaffee. But do go back to my lecture about what the Bonferroni is, because I think it is the most straightforward approach to doing a post hoc, and it is worth knowing. In this case, we had the same sample size for each group, so we're going to run the Tukey. And before we go any further, I always like to make a plot because I think it makes life easier for me. So I'm going to click on descriptive plot, scroll down. I'm going to move my condition over to a horizontal axis. And now what I'm going to see, if I click OK, is I have my post hoc test and a picture that helps me see it. So this gives you somewhat of a visual. Do not only rely on this picture though, because see how it goes from 6 to 10? It may be misleading. This just gives you a sense for what's happening, but you really need to check your data up here. So here's what this is saying. In this post hoc analysis, it would look the same if it were a Tukey or Chaffee in terms of the layout. This is saying the condition of currently feeling unrequited love versus imagined. this is their t-value, and this is their probability. You interpret these probabilities just like you would the p-value that we did for the ANOVA omnibus test. So here we see current versus imagined. They significantly differ from each other. Now this one is current versus retrospective. They didn't put current again because they're just trying to kind of be shorthand. So this is all of the current paired comparisons, current versus imagined, current versus retrospective. And so you can see here, because this says 1, that the p-value is not significant, which means that currently feeling it and retrospectively feeling it, they do not differ. Now we have groups 1 and 2 and 2 and 3, but we don't have this last pairing here. And so we're left to do this last pair comparison, which is imagined versus retrospective. And if we scroll over, this is significant. Now, it's a coincidence, or probably because I made the data up, that this says 0.14 and this one also says 0.14. It won't always do that. But when we're looking at these data, we can see that imagined versus retrospective are significantly different. So let's look at our picture and see what this means. This means that current and imagined, this gap here, that's a significant difference, right? So currently feeling unrequited love, oh, they feel it much worse than those who are trying to imagine what it would be like. This retrospective versus imagined is significantly different. Remembering how bad it felt is worse than trying to imagine what it would be like. But these two do not differ from each other. So currently feeling it and remembering what it felt like, it doesn't change the impact on how bad it feels. It feels equally bad to currently be in it versus to have once have been in it. So our job now is to convey these findings. Again, you're not allowed to look at these post hoc tests if the overall omnibus test was not significant, because this omnibus test is trying to maintain alpha at 5%. And it may show non-significance here, and then when you run the post hoc, these might come out significant, but those would be false interpretations. These are being held to less of a standard of that alpha 0.05 than the omnibus test is. So you're only allowed to move forward with a post hoc test if you have significant value for P. So just be careful with that, because it makes for a great test question. But the hardest part of ANOVA, I think, is when you do have significant post hoc, is interpreting how to put these in words for your readers. And you take as many sentences as you need to make sure it's clear that you've identified where the significance is and where the significant differences are not. You want to make sure you're clear with everyone. Imagine they cannot see this picture. Are you able to articulate clearly what it is saying if you do not have a picture? So we just calculated this in JASP, and we found that our observed F, or our calculated F, was 8.727. So notice we have steps 1, 2, 3, and 4 done. Now we can see from our JASP report that this was significant because the p-value was less than 0.05. So for step 5, we're still going to keep our rejection. We're still going to keep the rule of saying reject the null or fail to reject the null. But this time we can say we reject the null because the p-value, which we saw was 0.008, is less than 0.05. So you see how we are going to reject the null. And if I reject the null, I can no longer say that felt intensity of unrequited love does not differ by experience, but instead felt intensity of unrequited love differs by experience. Now for step 6, you might want to say, oh, okay, so felt intensity of unrequited love differs by experience. But you can't just leave people hanging like that. You need to tell them exactly where the differences were. So in step 6, this is where we have to go look at the post hocs to be able to make our conclusion. And so when we look back at the image, the plot that we saw, and the post hoc results that we got, we are going to use those to drive our conclusions. So for step 6, we're going to say, those that can only imagine unrequited love feel it much less intensely than those who have once felt it or are currently feeling it. See how I'm pointing out that the imagined are much less intensely feeling it than those who felt it or are currently feeling it? But I'm still missing something. I don't want to leave out this last statement. The latter two do not differ. I need to point out that having felt it once before and having be in the throes of it right now, they did not significantly differ when we looked at the post hoc. You can't leave this piece out, and many students do. You can't have the assumption that if I didn't talk about it, it wasn't different, because you just leave people hanging. So what we want to say is that those who imagine feeling unrequited love had a much less intensity of feeling it than those who were remembering it or those who are currently in it. But remembering it and currently in it equally feel the intensity. It's not like you forget it over time. They're equally intense with their feelings. So these two sentences would be required for a proper conclusion about this test. Now, sometimes it's going to take one sentence, sometimes it'll take two, sometimes it'll take four. There is really only no one way to do it, but you need to make sure you're clear who was low, who was high, who differed, who didn't differ.